Welcome to Covalent-Network Solids, sometimes just called covalent solids, but we're going to stick with the network name for just a bit because it'll help you understand really what's going on. Covalent network solids are atoms that are held together in large networks by covalent bonds instead of just intermolecular forces. So these are molecules that basically are bonded to each other. Now, sometimes this is just an element bonded to itself over and over and over again. It's actually the most common one we're talking about, but this can also happen with molecules. Now, these can be composed of either one element, like I said, typically carbon, sometimes multiple elements, like silicon dioxide or silicon carbide. Most common that we're going to deal with, though, is going to be carbon. So these types of solids are typically much harder, stronger, and have much higher melting points than molecular solids, which we're about to talk about. Because molecular solids are just held together by forces, by attractions. These actually got strong bonds between them. That's quite a bit stronger. So two common covalent network solids, or again, covalent solids, are diamond and graphite. Both of which are what we call allotropes, which are different forms of pure carbon. They're both carbon, but quite a bit different. Diamond, for example, are very, very valuable. Graphite is pencil lead. Same compound. So, diamond is a covalent network solid where every carbon is bonded tetrahedrally to 4 other carbon atoms. Basically meaning this. Now, keep in mind this is all three-dimensional. But that results in the hardest known material we have, with a stinking high melting point of 4,000 stinking degrees Celsius. Yeah, good luck melting a diamond. That's crazy strong because they're all bonded to each other. That's like the epitome of an example of teamwork, if you will. Graphite, however, is a covalent network solid of carbon that forms layers that are held together really just by forces. And the most common force, since this is all nonpolar covalent bonds, are dispersion forces. So graphite is more like this, where the individual layers, yeah, they're pretty strong, but they're just attracted to the others. So the layers are strong, but actually what's keeping the layers together, not really that strong. This allows for the various layers to slide past each other with a little bit of pressure, and even for some conducting of electricity, which is why we can write pencil lead. You're basically sliding off layers onto your paper. Now, again, within the layers of graphite, the carbons are very covalently bonded together, which actually means they still result in a high melting point. It's not quite as high as diamond, but you still got a layer of covalently bonded carbons. That's pretty strong. But that's really about it for covalent network solids. Just keep in mind that they basically form networks of covalent bonds. That's it. It's not really all that hard. So, thanks for watching.